Hello, hi everyone. Welcome to the Store in the Brand. This is your Siva sir. So today topic is electric current. So let's start. Electric current, the flow of charge, the rate of flow of charge is called electric current. Simply we can say flow of charge per unit time. Flow of charge through unit cross section area per second is called electric current. I equal to Q by T. We can say I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay. So 1 ampere is defined as 1 coulomb of charge flow through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called electric current. Okay. So I equal to Q by T. 1 ampere equal to 1 coulomb per 1 second. Done. So this is about electric current. In the conductor, so if you are taking the conductor, the charges are moving. So positive charge, negative charge, positive, negative, positive, negative, positive, negative, positive, negative. So charges are moving in the conductor. Charges are moving in the conductor. So it's only one electron, it won't move. So two electrons will not move. Number of charges are moving in the conductor. Number of charges are moving inside of the conductor. So the flow of charge. Okay. The flow of charge. Charge is flowing in the form of integral multiple. Means number of charges. Many. Okay. So that's why we are considering it is quantization of charge. Quantization of charge means many charges are moving in the conductor. Number of charges are moving in the conductor. Right? So that's why we can say number of charges are moving in the conductor. So that's why we can say charge is quantized. Charge is quantized. Okay. Now we can take Q equal to Ne. Q equal to Ne. So plus or minus we are taking. Plus or minus. Okay. So plus or minus means positive charges are there, at the same time negative charges are there. So that's why I'm taking I equal to T. I equal to Ne by T. Ne by T. So then we can take number of charges. So on one electron, 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many charges are present? In 1 coulomb, 1 by 1.6 into 10 power minus 19, that is nothing but 6.25 into 10 power 18 electrons in 1 coulomb. In 1 coulomb, 6.25 into 10 power 18 electrons are present. Okay, so just check once. Electric current is nothing but the rate of flow of charge, SI unit of Electric current is called ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. So number of charges are moving in the conductor. So that's why charges are quantized. Q equal to Ne, I equal to Ne by T. So on 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 6.25 into 10 power 18 electrons are present. Okay, so this is about electric current. Now we will discuss about circuit, electric circuit, electric circuit. So we will discuss electric circuit. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Okay, so here, so I'll take this the cell. So two or more cells added, battery. So switch, closed switch, and next one bulb. So I'm taking the bulb, closed bulb, sorry bulb. So bulb symbol. So current is passing, positive terminal, negative current is passing. So bulb is glowing because circuit is closed. Current is passing from positive terminal to negative terminal. Here there are two types of current. One is conventional current. Conventional current. Second one is electric current. Conventional current and electric current. Conventional current. So the flow of positive charges. Charges are moving from positive terminal to negative terminal. Okay, so that's why we are considering as a conventional current. Before finding proton, neutron, electron, all those things, so already given statement, that is flow of positive. So charges are moving from positive terminal to negative terminal, that is electric current. That is what flow of positive charges. Okay, so after knowing that, so electrons movement, because of the electrons movement, current is flowing. So that is the reason. So flow of electrons is known as electric current. Electrons are moving opposite to the flow of positive charges. So conventional current will be considered as a flow of positive charges. Electric current will be taken as flow of electrons. Okay. This is a conventional current and electric current. So these are the two types. Next one we will discuss about one more. That is about electrical appliances. We'll discuss electrical appliances. Electrical appliances. So here you can consider electric circuit. Cell. Second one is battery. Cell, battery. Switch. Open switch. And fourth one is closed switch. Closed switch. Closed switch. And fifth one is cell battery open switch close switch. Next one resistor. Resistor. Sixth one is rheostat. Rheostat. So this is the rheostat. 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 Next one is ammeter. Seventh one is ammeter. Positive terminal, negative terminal. Coming to voltmeter. Positive terminal, negative terminal. Next, ninth one is wire joining. 10th one is wire crossing. Wire crossing. So once again, cell. Here you can see cell, battery, open switch, close switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing. So these are the electrical appliances. Electrical appliances. So now we will discuss about potential difference and electrical potential. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So here I am taking this conductor. So electrical potential difference, potential difference, potential difference. So here this is a point A and point B. We are doing some work to bring unit positive charge from one point to another point within the conductor. Within the conductor, we are doing some work to bring unit positive charge. Then V equal to W by Q. Okay, SI unit of potential difference is volt, SI unit of work is joule, and SI unit of charge is coulomb. Okay, so 1 volt equal to 1 joule by 1 coulomb. So that is a potential difference. Coming to electrical potential. So I'll discuss about electrical potential. Electrical potential. So electrical potential is nothing but, so we can see work done to bring, so this is infinity, positive charge is there, we are doing some work. This is electrical field or required field. So we are doing some work to bring, unit positive charge from infinity to the required field, that is called electrical potential. So this is about potential difference and electrical potential. Formula is same, V equal to W by Q. So 1 volt is nothing but 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor is called potential difference. From infinity to the required field is called electrical potential. Okay, so next one. So Ohm's law, we'll discuss about Ohm's law. Ohm's law. Here The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Meter. So here 4 cells. 1, 2, 3, 4. 4 cells. So here close switch, voltmeter. So here is X and Y. So I'm taking nichrome wire. Positive terminal, negative terminal, positive terminal, negative terminal, current is flowing. So here you can see. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. The potential difference across ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to V equal to IR. Okay. So materials required. What are the materials required? We'll discuss now. Materials required. Materials. So material statement is the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. That is a statement. Now materials required. Coming to materials required. First one 4 cells. 4 cells of 1.5 volts each. And coming to the next one, nichrome wire. Nichrome wire is an alloy of nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. And coming to the next one, ammeter, voltmeter. Ammeter and voltmeter. Voltmeter. So switch and fifth one is connecting wires. Connecting wires. Connecting wires. So next one, procedure. Procedure is, so first connect one cell and note down the reading of ammeter and voltmeter. First connect one cell and note down the reading of ammeter and voltmeter. And next connect two cells and same process. Note down the reading of ammeter and voltmeter and repeat the process for 3 and 4. 3 and 4. Mention the values in the tabular form given. So this is the tabular form. So serial number of cells, ammeter, voltmeter, V by I, that is nothing but R. V equal to IR, R equal to V by I. Okay, so you have to note down in the tabular column. Next, 1, 2, 3, 4, 4 cells. 1, 2, 3, 4. Okay, 4 cells you have to take. Now, so you can take, if you draw the graph for VI, V on y axis, I on x axis, the graph is straight line. The graph is linear starting from origin. The graph is linear starting from origin. Okay. So VI graph is straight line. So for ohmic conductors and for non-ohmic conductors, it is curve. Ohmic conductors. And the second one is non-ohmic conductors. Non-ohmic. So what is meant by ohmic conductors? What is meant by non-ohmic conductors? Ohmic conductors are nothing but the conductors which obey Ohm's law. Those are called ohmic conductors. Non-ohmic conductors are nothing but the conductors which does not obey Ohm's law. Those are called non-ohmic conductors. Ohm's law, ohmic conductors and non-ohmic conductors. So these are the difference. I hope it is very clear. Okay, so this is about Ohm's law. So once again, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to V equal to details required. 4 cells, 1.5 volts each. 1.5 volts each, 1.5 volts each, 1.5 volts each. And nichrome wire, ammeter, voltmeter, switch, connecting wires. So procedure: first connect one cell and note down the reading of ammeter and voltmeter, and connect two cells and note down the reading of ammeter and voltmeter, and repeat the process for 3 and 4. Mention the values in the tabular form given below. Serial number 1, 2, 3. So number of cells, ammeter, voltmeter, ammeter reading, voltmeter reading. Ammeter reading is the current, voltmeter is the potential difference, V by I, that is nothing but R. So if you draw the graph for VI graph is straight line starting from origin. Okay, so this is for ohmic conductors. For non-ohmic conductors, it is curve. So what is meant by ohmic conductors and what is meant by non-ohmic conductors? Ohmic conductor means the conductor which obeys Ohm's law. Non-ohmic conductor, the conductor which does not obey Ohm's law. Here, the potential difference, we said right, the potential difference across the ends of the given metallic conductor is directly proportional to current at a constant temperature. At a constant temperature, and physical conditions also same. Okay, so constant temperature we have to mention, and physical conditions also we have to take, but that and constant temperature is very important. So those conditions it should obey, then only we can able to say ohmic conductors, right? Next, so resistance is nothing but now. So we'll discuss about resistance. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. So R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. So rho is the resistivity. R is the resistance. R is the resistance. Rho is resistivity. Okay. So resistance is nothing but the phenomena of opposing the electric current. Resistivity. And resistance depends on length and area of the cross section, but resistivity does not depend. So both depends on temperature and material of the medium. Okay. So formula R equal to rho into L by A, or rho equal to RA by L. SI unit of resistivity is very important. SI unit. SI unit. That is rho equal to RA by L. So rho equal to SI unit of ohm meter square by meter. Meter get cancel, ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. So that is very important. Okay, done. Next, resistors are connected in series combination. Resistors are connected in parallel combination. We'll discuss. Resistors are connected in series. Resistors are connected in series. So resistors are connected in series combination. So I'm taking 1, 2, 3 resistors R1, R1, R2, R3, V1, V2, V3, ammeter. From Ohm's law, B equal to IR. So in this, current is same. IS equal to I1 equal to I2 equal to I3 equal to I, because same current is flowing, but potential difference is different. So that's why we are taking Vs equal to V1 plus V2 plus V3. IRS equal to IR1 plus IR2 plus IR3. So I am taking common RS. So R1 plus R2 plus R3 I get cancel. RS equal to R1 plus R2 plus R3. Okay, if n number of resistors are connected in series combination, if n number of resistors are connected in series combination, RS equal to NR. If n number of resistors are connected in series combination, RS equal to NR. Clear? So resistors are connected in parallel combination. Now we will discuss about resistors are connected in parallel combination. See. So here you can observe potential difference is same, but current is dividing into three parts. That is Vp equal to V1 equal to V2 equal to V3 equal to V. From Ohm's law, V equal to IR, I equal to V by R. Then, so overall current, if you are taking IP equal to I1 plus I2 plus I3. Then V by Rp equal to V by R1 plus V by R2 plus V by R3. Okay, so I am taking V common. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. VB get cancelled, so 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected in parallel combination, 1 by Rp equal to n by R. Rp equal to R by n. Okay, so this is about Resistors are connected in parallel combination. Resistors are connected in parallel combination. Okay. Now, so we'll see. So now we will talk about heating effect of electric current. The source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current. So V equal to W by Q, W by Q, V equal to W by Q, W equal to V equal to W by Q. So W equal to V into Q. So P equal to W by T, VQ by T. So Q by T is current. So V into Q by T is VI. Okay. So P equal to VI. So E equal to P into T. Energy equal to power into time. VI into T. V equal to IR. Substitute V equal to IR in this form. Then we'll get, so whatever the energy is given to the conductor, that will be converted in the form of heat. H equal to IR into I into T. So then H equal to I square RT. Heat produced in the conductor. Okay. So I hope it is very clear. So heat in the conductor is H equal to I square into RT. So heat produced in the conductor is directly proportional to square of current, is directly proportional to resistance, is directly proportional to time. Okay. So this is about heating effect of electric current. Applications of heating effect of electric current: electrical toaster, electrical iron box, and electrical heater, electrical oven. So like that, so many examples we can take. So this is about electric current. If you like the content, if you like the channel, if you like my explanation, do like, share and subscribe to Student in the Brand. So thank you so much for joining and attending and listening my class. This is our Shiva sir signing off.